Okay.
Yes, sir.
Be very careful about this. You have to use this VDD and ground every time you make the design. Without this, your mark will be reduced. Okay. Remember this thing. After the result, some of you raise the question, sir, I wrote the same thing like he did. Why I get the less mark, right? These are the reason. These are the reason for which you might get less mark. Some of you might forget about this VDD. Some of you might forget about this ground. Some of you just write like this. Some of you just write like this. This is not the symbol of ground. This is the symbol of VDD. Some of you keep it like this. Some of you forget to give the bubble. Can you see some bubble? There's a bubble, right? There is a bubble. Some of you forget to give the bubble. Some of you forget to give like this. Some of you will do it. You are not giving the get. So these are the reason for which your mark reduced. Okay, don't be surprised if you say, sir, he did same thing, I did same thing, why I get less mark? Maybe because you forget one ground, maybe because you forget one VDD, maybe because you forget one bubble, maybe because you forget the gate. Okay, got my point? Understood, my dear student?
Yes, sir. Yes, sir.
Do not forget. Do not forget. See, the design has to be perfect. If it is not perfect, it is not a good design. Okay, now here, look at this. This is the source of the PMOS. This is the drain of the PMOS. This is the drain of the NMOS. This is the source of the NMOS. The drain are connected. This is a gate. This is the gate. And the gates and gates are connected. Gates and gates, where they are connected, they are the input. Drain, they are the what? The output. And source, they are the power. Gates are the input, drains are the output, and source are the what? Power. Understood, my dear?
Yes, sir.
Always remember. Now I'm going to erase these. So here you have what? You have one PMOS, one NMOS. They are connecting together and they forms a CMOS. They forms a CMOS. Got my point?
Yes, sir.
CMOS. Okay. Now here, this is your input A. This is your output Y. Remember, output Y is always a bar. Here, this is a NOT gate. This is actually a inverter, an inverter, not gate. This NOT gate. If you give A, your output becomes what? A bar, right? Got my point?
Yes, sir.
Okay. So this complementary MOSFET, that means the CMOS, is actually a NOT gate. So one CMOS is actually a one what? One what? NOT gate. Understood? Now how this thing works as a NOT gate, I will explain. So I'm going to I'm going to share my screen rather than the whiteboard. I'm going to go to the software here. This is the software we will learn in our lab number 6, no, not 6, 7, 8, 9, 10, 11. Okay. This is a software we will be learning about in our lab number 7, 8, 9, and 10, and 11. Okay. But we are going to use it before. Now I'm going to use a PMOS. This is a PMOS. Excuse me. Okay, this is the PMOS. What is the sizing? Sizing is 2. This is an NMOS. The sizing is 1. So 2:1. So you can actually make it 3:1 actually. So make it 3. 3:1, right? Remember, this is W is 3 and the W is 1. So 3:1. So this is not important actually. The important thing is this one. This is the drain, and the gate are connected. The source will be here. Not source, the ground. The ground is connected to the source. And the VDD. Now the symbol of VDD can be like this as well. Okay, it's your wish. Here connected. This will be our input. This will be our output. Now the input, we can use a button, right click, double click. We're going to name it A. As output, we can use a what? We can use a what? We can use a LED, or we can use a capacitor. Our wish. But capacitor, we actually do not see the effect because it is a charge. Charge, you cannot see the charge, right? Can you see the charge? Can you see the current? No, you cannot see the current. So that's why we are going to ignore the capacitor for this moment. We are going to use LED. Double click. I'm going to rename it as Y. Can you see it? Is it better or this is better? Which one is better? Black or blue? Black or white?
Black is better.
Black is better. Okay. So I'm going to click run. See this one. When our input is 0, can you see input is 0? That no color here. That means it is 0. That time our output is what? 1. Why? Because there is a red color. How this is happening? Because always remember this. PMOS works at 0. That means if you give 0, PMOS is on. If you give 1, PMOS is what? Off. For PMOS works at 0. That means if you give 0, your PMOS is on. If you give 1, your PMOS is off. Okay? NMOS, however, is opposite. That means NMOS works at what? 1. That means if you give 0, it is off. If you give 1, it is on. Okay? Remember this throughout your life. Throughout your life. Do not forget. Do not forget. That means if you give 0 to PMOS, it is on. If you give 1, it is off. For NMOS, if you give 0, it is off. For 1, it is on, right? So how much you have given here? 0, right? For 0, which one will be on? PMOS or NMOS? PMOS is on. That on means it will be short, right? That means the current can come.
Yes.
Okay, let me use the red color. That means current can come, right? Now for 0, NMOS will be what?
NMOS off.
See, it is disconnected, right? Yes. So this current is coming. It cannot go down. Can it go down? No, it cannot go down because it is open. So where the current will go? Where the current will go? So the current, the only way it can go is through the LED to the ground, right? Through the LED to the ground. So it will go to the ground eventually, but it cannot go to the ground directly. So it will go to the LED, then go to the ground, right? So by doing so, your your LED is on, right? Your LED is on because current is going, right? Current is going. That means your LED is on. And one more thing, what is the voltage here? Can anyone say what is the voltage here? What is the voltage at this point? 5 volt. 5 volt because it is short, right?
Yes.
This line is short. That's why here the voltage is 5. So if you give 0, that means 0 volt, you are getting 5 volt as output. Understood my point?
Yes, sir.
Okay. Now let's go to the next one. So if I give 1, what will happen? If I give 1, how much is your output?
Which MOS? PMOS or NMOS?
No. Your LED.
Yeah, 0, sir.
0. Why? Because if you give 1, your what? Your PMOS is off, right?
0. Yeah.
PMOS is off. What about your NMOS?
NMOS is on.
NMOS is on. That means
it is 0.
That means okay. Let me show you something. That means this ground is short, right? At this pin you have a ground. At the other pin you have a ground. So in the 2 pin of the LED, we have the same ground, right? If you have ground in both pin of your LED, will the LED be on? Okay, let me try in another way. What is the voltage here?
5.
No, not now, not 5 anymore. It was 5 when it was connected.
Zero, zero.
Yeah.
Now 0, right? Now it is
Yeah.
connected. This is short to 0, right? Can you see that?
Yeah.
Here the voltage is
Yes,
0.
sir.
So at 0 volt, the LED will not be on, right?
Yes.
That's why it is 0. So if you give 0, your output is 1. If you give 1, your output is 0. So it is what? It is not get. It is what?
Not gate.
Not get. Understood, everyone?
Yes, sir.
Okay. So I'm going to clear the screen. And I'm going to go back to the whiteboard. This is your CMOS inverter, CMOS not get. Remember, not get. CMOS not. Now we will use CMOS NAND. CMOS NAND. For NAND, let me design something. VLSI is much easier in online class, okay? To teach VLSI is easier in online class. In offline class, I need to draw a lot of things. And it is not very much understandable. So I am happy that I am taking online class to teach VLSI. Got my point?
Yes.
Maybe some other courses, this is tough. People do not understand, people do not teach, maybe something like that. Okay. I'm going to use a different color. So let's say you have two input, one A, another one is B. So A is connected here and also connected here, right? Okay, let's use a different color. Let's say B is connected here and here, right? We can do this sort of design. We can actually make this sort of design like this, or we can write A here. We can write A directly here and B directly here. And again, we will repeat A here, B here. Understood? Understood?
Yeah.
Then we can
Yes,
actually
sir, yeah.
we can actually remove this. We do not need this. So this is much cleaner design. So when you design something in your paper, that means on your paper, you design like this. Okay, you do not have to draw all those wires. Now this part are PMOS, right? Can you see that? And this part is what? NMOS.
NMOS.
How do I know? Because PMOS has a bubble. Can you see the bubble?
Yes, sir.
Yeah.
And NMOS do not have any bubble. So these are the difference. So PMOS will always be at the top. NMOS will be drawn at the bottom always. Why? Because we normally draw our VDD at the top and ground at the bottom, right? That's why. That's why VDD is at the top, ground is at the bottom, and that's why PMOS is at the top, NMOS is at the bottom. Now our output will come from where? Our output will come from at the middle, where the NMOS and PMOS are connected. Always remember, our output will be from the junction point of what? Junction point of what? Junction point of PMOS and NMOS. Always remember. Understood?
Yes, sir.
Sir, repeat.
Okay, our output will always be at the junction where the PMOS and NMOS are connected. They are mixed. Okay, they are connected. That is our output point. Got my point?
Yes.
Our PMOS and NMOS, where they are connected, that is our output point. So this is our Y. Y will be A, B bar. Because this is NAND gate, A, B bar. That means if you give 0, 0, your output is what? 1. 0, 1, your output is 1. 1, 0, your output is 1. 1, 1, your output is
0.
0. Okay? Let's check whether this is correct or not. Let's check. Let's go to the software. Turn it off. I do not need this anymore. Okay. I need 2 PMOS, that's why I'm going to copy it. I need, okay, let's zoom it out. I need 2 NMOS, so I need to copy it. The sizing should be double. The sizing we will learn later, no problem, do not worry about this. So I'm going to connect these. This is our A, so I need B as well. Double click, this is our B. So which one is our A, which one is our B? It completely depends on you. This one is A, this one is B, this one A, this one is B. That doesn't matter. It depends on your wish. Got my point?
Yeah.
Doesn't matter. These two are A. This one is B. Okay, understood?
Yes, sir.
Okay, now let's check our circuit is working or not. When I run, both of them are 0, 0, right? Zero, 0. What is our output?
1.
1. Okay. Why they are working like that? When they are 0, 0, that means the A PMOS is on. A NMOS is off, right? Can you see that? It is off.
Yes, sir.
Because at 0, PMOS is on, NMOS is off. B is 0, so PMOS is on. And NMOS is off. So the current can come and go to this way and go to the LED, right?
True.
Or the current can come, go to this way and go to the LED, right? That means in both way, current can come and go to the LED. Understood?
Yes, sir.
Okay, that means the LED will be on. Now, let's try another. Which one? I'm going to use 0, 1, 0 and 1. Okay? So what I have done here, you can see your this is 0, so this is on, this is off. This is 1. So B, this is off. Can you see that? This is off.
Yes, sir.
So this is what? Now this is on. But what is happening? What is happening here? This current cannot go this way. Can it go?
No.
No. But this current can go this way and go. Can it go to the ground?
No, sir.
No. Why not? Because this is off, right?
Yes, sir.
So if this is off, so what is happening? This current will come. It will go to the LED and go to the ground, right? So the LED will be on. Got my point?
Yes, sir.
Okay. And the ground is disconnected. So that's why we can write for 0, 1, output is what? Still 1. Okay? Now let's try another one. Let's try
1, 1.
no, 0, 1. No, 1, 0. So
1,
let's try
0.
1,
1,
0.
0. 1,
1,
0.
0.
Yeah.
So what is happening? The same thing will happen. So in this case, this is off, but this is on.
B is
This is on, but this is off. So what is happening here? What will happen actually? the current cannot come this way, can it?
Oh,
No, but current can come this way, right?
yes, sir.
After that, can it go to the ground?
No, sir.
No. Since it is not going to the ground, so what will happen?
Going to the LED.
Oh, the
It will
LED.
go to the LED to the ground, right? That means for this, you are actually getting what?
1 0.
1. For 1 0, you are getting 1, right?
Yeah.
Okay. Very good. You are understanding.
1 1.
Okay. Now 1 1, right?
Yes, sir.
Yes. The interesting one.
Yeah, interesting one, right? It's very interesting. VLSI is interesting.
Yes, sir.
For 1 1, so what is happening? This is off.
And,
This is off.
All of
This is 1.
and
This
one.
is 1, right? On. So what is happening?
Yeah.
No current
Cancel
cannot
it.
come. No current cannot come, right? So
Yes, sir.
no currents are coming, but your ground, now your ground is connected, right?
Yes, sir.
it will be zero.
If your ground is 0, if your ground is connected, that means you are actually getting what?
0.
0 for
Zero.
0, you are getting 0.
Yes.
So your truth table is correct, right?
Yes, sir.
Yes, sir. Yes, sir.
Go to the truth table. Truth table is correct, right? Can you see that? For 0 0 it is 1, for 0 1 it is 1, for 1 0 it is 1, for 1 1 it is 0.
Yes.
So I believe you understood this thing very well, right?
Yes,
Okay. So that is
Yes,
your NAND gate. NAND gate. So can anyone tell me what will be our AND gate? You think 1 minute, okay? You think 1 minute, then tell me what will be our AND gate?
And it will be 0.
No. Design of the AND gate.
Engage, sir, is
Think. I'm going to give you 1 minute. Think.
okay, sir.
Okay.
Yes, sir. The opposite of this
Tell
one.
me. Almost like this one, right?
Opposite, sir.
Opposite. How can you say that opposite?
Because, sir.
No. How opposite? You tell opposite. Okay. What is the opposite thing?
Opposite of NAND gate. I think
NMOS
like-
will be on top, sir.
NMOS will be on top? No.
Yeah.
No. Remember, you are going well, but never, your NMOS will never be on top. Your PMOS will never be on the bottom. Think again. You are in the right track. Think again.
Sir,
Yeah.
maybe the BMOS will be as serious.
Okay, you are wrong again, but very good. for you.
Okay, sir. I will try. I will try.
Wait. Who said PMOS will be in series?
Me, Mahmoud, sir. Mahmoud.
Mahmoud.
Rule 21. Yes, sir.
No, you are wrong, but very good for thinking this. We will be needing this thing in our next circuit, okay? Very good for thinking this. We have a circuit that has PMOS in series and NMOS in parallel.
Yes,
That
sir.
is NOR gate, NOR,
Oh,
okay? Very good for thinking that, okay? Remember, we need this. But, okay, I'm going to give you one hint. That hint, okay, this one. This is a NAND gate, right?
yes, sir.
Okay, what if we connect a NOT gate? Now, what is the NAND gate equation? AB. What is the equation here? AB bar, right?
Yes.
What if we
Yes,
connect a
yes.
NOT gate? Double bar, right? Double bar?
Yes, sir.
What is the double bar? It will cancel each other, right?
Yes, sir. Only AB.
Only AB. Now it become an AND gate, right? Can you see that?
Engage, yes, sir.
Okay, so what if we connect? What if we connect a NOT gate here? What if we connect a NOT gate? What is a NOT gate? This is a NOT gate, right?
Yes.
So y is equal to AB. Okay? So always remember your CMOS, whatever you are going to design with your CMOS, that will always have a bar. Always, always. At the beginning, whatever you're going to design with CMOS, that will always have a bar. If you want to remove the bar, you have to use another CMOS. Got my point? Whatever you are going to design with CMOS, that will have a bar. Whatever you are going to design with CMOS, that will have a bar. But if you want to remove the bar, you have to use one more CMOS extra. Got my point? Got my point?
Yes, sir.
Because CMOS itself is a NOT gate. CMOS itself is a what? A NOT gate. One CMOS is one NOT gate. So whatever you are going to design with CMOS, it will always have a bar. Okay, my dear? Understand this very carefully, because this course is a very complicated. This is a very funny course. This is a very interesting course, and this is a very hard course as well. Because if you do not understand the design, this sort of design, there are a lot of designs like this. If you do not understand the design, you will not be able to do good in the exam. Okay? Got my point? And remember, this course, not everyone will shine. Some of you will do very good, and some of you will not do very good, because you cannot do anything by memorizing. No, not possible. Not possible. Understood my point? Not possible by memorizing. Okay? This is the AND gate. So if you want to see how an AND gate behaves, we can go to the screen and we can see. Okay? Let's see. So I need to copy one PMOS. No. PMOS. I need to copy one NMOS. Like that. This is our output. This is our input. This is our VDD. This is our ground. This is our AND gate. Let's check. For 0, 0, it is 0. For 0, 1, it is 0. For 1, 0, it is 0. For 1, 1, it is 1. Right? This is the AND gate. Understood, everyone? Hello?
Yes, sir.
Yes, sir. Yes.
Okay. So this is how actually we design things. We will actually do this sort of things. Okay, this is an AND gate. So whenever there is no bar, so what is the equation of AND gate? Y is equal to
AB.
AB. When there is no bar here, no bar, that means you have to use a what?
AND gate.
A NOT gate. You have to use a NOT gate at the output. Got my point? When
Okay.
there is no bar means you have to use a NOT gate. Now, what if I tell you design an AND gate with 3 input? How to do that? 3 input AND gate, or actually 3 input NAND gate. Okay, if I tell you design a 3 input NAND gate, what will be your result, or what will be your circuit? How will be your circuit? Okay, I'm going to repeat this. If I tell you design a circuit that has 3 input, like ABC bar, that means 3 input NAND gate, not 2 input. So what change will be there? What change? What change will be there? What are the changes? What you have to do extra? Anyone?
We will make P1 and N1.
P1 and N1?
Yeah,
Yes, you have to add, right? Extra.
two extra in the yeah,
Exactly. So you have to add one more PMOS here.
and another NMOS.
This will be your C, and you have to add. Oh my God. You have to add one more,
Another NMOS.
Almost.
and I cannot complete the ground. So you understand, right? There will be ground.
Yeah, yes, sir.
This is C. So this will be your Y. So Y is equal to A, B, C bar. Now again, if I do not need the bar, then
We will add the NOT gate.
like this. Understood?
Yes, sir.
Exactly like that. So A, B, C that time, not get. Understood, everyone? Okay.
Okay.
So now understand this thing. When the equation. Okay, let me delete this. When the equation is multiplication, like AND gate, AB. When the equation is multiplication, that time your NMOS is in series and your PMOS is in parallel. So remember this, whenever you have multiplication, your NMOS is series and PMOS is parallel. So when you have addition, this thing will be opposite. Like NMOS will be parallel, PMOS will be
Serious.
series. Always remember this. If you remember this, your design will be very much easier. That means we only see the multiplication. We haven't seen the addition yet. We will see later. Now after this. So if you have multiplication, your NMOS will be in series, your PMOS will be in parallel. And if you have addition in your equation, here, AB, it is multiplication or addition? AB, multiplication or addition?
Multiplication, sir.
So that means this one.
Yes.
Okay. Your NMOS will be series, PMOS will be parallel. If this was A plus B,
It will be in.
it will be NMOS will be parallel, PMOS will be series, right?
Yes. Yes,
So
sir.
okay, let's try NOR gate. So NOR gate means A plus B bar, right? So what I just told you, before 2 minutes or 3 minutes.
BMOS is a serious.
Yes, PMOS will be in series, right?
Yes, sir.
And NMOS will be ground is very important. If you do not give ground, you will get 0. So from the connection in between PMOS and NMOS will be what? This is the PMOS side, this is the NMOS side. At the middle, you have your output. So this will be A plus B bar. Always remember, whatever you are going to design will have a bar. Whatever. At the first stage, there will be a bar. Okay? At the first stage, there will be a what? A bar. So this is your A. This is B. This is your A.
B.
This is your B. Okay? You got it?
Yes, sir.
Okay. Now, let's see how this thing works in our software. Okay. We're going to arrange this thing like this way. Double click this time your
Gate 1.
this will be 1 1. So you do not have to understand this thing right now. You can understand this thing later. This one will be 6. This will be 6. Okay, I can connect them. Connect them. Connect them. This one is A. You need to go there. This is B. Okay. This is also A. And this is B. Understood? A and B. And this one will be our Y. Output. Okay. Now see. Let's run.
0, 0
For
is
0, 0, it is 1, right?
Yes.
Let's see for how this thing works. For 0, it is on. This is on. This is off. This is off. So current can clearly comes from up. It cannot go down because both of the lines, both of the both of the ways are what? Are closed, right? Now are opened. So that's why they cannot go there. The only way they can go is what?
Through the
To the LED. So
From
it is 1. Okay? Got it?
Yes, sir.
Okay. Now what? Now let's try. Let's try 0, 1. When you have 0, 1, the
0.
output is 0. Why? Because for 0, it is on. That's okay. But this is off because it is NMOS. For B, that is 1. So it is off. And this is on, right? So what is happening? Current cannot go to the LED. Why? Because it is off, right?
Yes, sir.
But this ground is going to the LED, right? This ground.
Yes, sir.
That's why your output is what?
0.
Your output is 0. Understood?
Yes, sir.
Okay. Again, for same reason, if you give 1, 0, your output is 0. If you give 1, 1, for same reason, your output is also 0. So that is the truth table of NOR gate. Got my point?
Yes, sir.
So if we need OR gate, or what we will do?
We will add one P MOSFET and N MOSFET.
Yes, one NOT gate. Okay.
Yeah.
We'll have a NOT gate. What if? Okay. What if we have A plus B plus C bar? This one. Then what will happen?
We will add another one, sir.
You will add another one here, and you will add another one here,
Yes, sir.
or here. Doesn't matter. Got my point? Doesn't matter. Where you will add doesn't matter. You can add here at the middle, or here doesn't matter. Got my point?
Yes, sir.
Okay. And for these, no. And for these, A plus B, you have to use a NOT gate here. That's it, right? Got my point?
Yes, sir.
So today we will not go further. Tomorrow, that means in the next class, we will, because I want you to digest this. I want you to digest. Got my point? I want you to digest this thing, because if you go further, you will not understand. Because if you do not understand this CMOS designing, your whole course will be a failure if you do not understand this CMOS very clearly. I want you to see the video, what I am going to upload today. Okay? I want you to see video again and again, so that you do not miss any small detail. If you are ready for the next class, I will start the next class. Okay? And tomorrow, that means that in your next class, we will learn much complex design, much complex design. Got my point?
Yes, sir.
Yes, sir.
So how many of you are here?